Hello viewers, welcome you in today's sessions on Techniques of Counting Part 1. It is based on Unit 4th of first course Foundation in Mathematics and Statistics of the program Postgraduate Diploma in Applied Statistics. First of all, we have to define what we mean by definition of factorial, and then we will define what we mean by principle of multiplication, then fundamental principle of addition, and at last we will define what we mean by subtraction principles, and we will discuss their applications. First of all, factorial is nothing but it is the product of the first n natural numbers, and you see it is n into n minus 1, n minus 2 and so on up to 3 into 2 into 1. This is the product of the first n natural numbers, and this product is denoted by n factorials. If n equal to 0, then we define factorial 0 is equal to 1. We see that in factorial n, this can also be written as n at it is, and this n minus 1 into n minus 2 into n minus 2 and so on 3 into 2 into 1. This is nothing but this is the product of from 1, 2, 3 and so on up to n minus 1. So factorial n can also be written as n into factorial n minus 1. Factorial n can also be written as n, let us take it at it is, then n minus 1 at it is, then this from n minus 2, n minus 3 and so on 3 into 2 into 1. This is the product of first n minus 2 natural numbers. So factorial n can also be written as n into n minus 1 into n minus 2 factorial, and so on. We can break factorial n at any place. Let us take an example. We have to evaluate some factorials. In factorial 8 is nothing but by definition it is equal to the product of first 8 natural numbers, 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1, and the product of these first 8 natural numbers is 40,320. This is the value of the factorial 8. Next part we have to evaluate is factorial 4 into factorial 3. Factorial 4 can be written as by definition 4 into 3 into 2 into 1, and factorial 3 by definition can be written as 3 into 2 into 1, and in first bracket product 4 into 3 into 2 equal to 24, and in second bracket we have 3 into 2 into 1, that is equal to 6. 24 6 is 144. In third part we have to evaluate factorial 10 divided by factorial 8 into factorial 4. Let us break factorial 10. By definition it can be written as 10 into 9 into factorial 8. Why we have break it at factorial 8? Because in denominator we have factorial 8, so that we can cancel this factorial 8 with factorial this in factorial 8, and this factorial 4 by definition can be written as 4 into 3 into 2 into 1. So this factor, after cancelling factorial 8, we have 10 into 9 divided by 4 into 3 into 2 into 1, and after if we cancel other common factors, 9 cancel with 3 3 are 9, and 2 10 can be cancelled with 2 2 5s are 10. In numerator we have 5 into 3 15, and denominator we are left with only 4. So the final answer is 15 by 4. In fourth part we have to evaluate value of factorial 5 plus factorial 4. Factorial 5 is by definition 5 into 4 into 3 into 2 into 1. It comes out to 120, and factorial 4 we have already calculated it is 4 into 3 into 2 into 1, it is equal to 24. So factorial 5 plus 4 is 120 plus 24 is equal to 144. Factorial 6 minus factorial 4. Factorial 6 by definition if we write it as 6 into 5 into 4 into 3 into 2 into 1, it comes out 720, and minus factorial 4 is 24. So after subtracting 24 from 720 we get 696. Let us take another example. Express the following in terms of factorials. Here given some products, and we want to convert these products into terms of factorials. This 5 into 6 into 7 into 8 into 9 into 10. Recall the definition of the factorial. We need the product from 1 to up to that numbers. Here we have 5, 6, 7 and so on up to 10. So but we need 1, 2, 3, 4. So what we can do is we can multiply by 1, 2, 3, 4, and we can also divide by 1, 2, 3, 4. So that both equations remain same. But in numerators we see that it is a product of 1 to 10. So it is equal to factorial 10, and in denominator we have 1, 2, 3, 4, it is equal to factorial 4. So in terms of factorial, this can be written as factorial 10 by factorial 4. In second part, we are given 4 into 8 into 12, 16 into 20 into 24. We see that 4 can be written as 4 into 1, and 8 can be written as 4 into 2, 12 can be written as 4 into 3, 16 4 into 4, 20 can be written as 4 into 5, 24 can be written as 4 into 6. So we can take 4 common, but 1 4 we get from here, 1 from here, 1 from here. So we have 6 times 4. So 4 is to power 6 common, and from 4 we are left with only 1. From 8 4 common, we are left with 2, and similarly 3 4 5 6. So this can be written as 4 is to power 6 into factorial 6. Take next part, 1 into 3 into 5 into 7 into 9 into 11, product of the first 6 odd numbers. What we need to convert it into factorial, we need even numbers, because even numbers are missing. So we can multiply with 2, 4, 6, 8, 10, and we can also divide 2, 4, 6, 8, 10, because we cannot multiply only. If we want to multiply, we have to divide by that thing. Now in numerator we see that this is the product of 1 to 11 consecutive natural numbers, so it is equal to factorial 11. But in denominator we see that 2 can be written as 2 into 1, 4 can be written as 2 into 2, 6 can be written as 2 into 3, 4 can be written as 2 into 4, and 10 can be written as 2 into 5. 2 commons, but we have 5 2's. So 2 is to power 5 common. Inside we get 2, 1 into 2 into 3 into 4 into 5. And 2 is to power 5 is 32, and in bracket we have product of first 5 natural numbers, so it is equal to factorial 5. So this can be written as factorial 11 upon 32 into factorial 5. And the last part of this example is 2n into 4n into 6n into 8n, and 2n can be written as 2n into 1, 4n can be written as 2n into 2, 6n can be written as 2n into 3, and this 8n can be written as 2n into 4. 2n common, but we have 4 times 2n. The 2n is to power 4 common, and from here we have 1, from here we have 2, 3 and 4. So inside bracket we have 1, 2 into 3 into 4. But this is the product of first 4 natural numbers, so it is equal to factorial 4. So we have converted all these expressions in terms of factorials. Let us come on the first principles of the counting, that is known as fundamental principle of multiplications. In these principles, actually what we do, suppose we want to perform a job which is can be completed in n phases. A first phase, suppose, can be completed in m1 number of ways, and second phase can be completed in m2 number of ways. Third phase can be completed in m3 number of ways, and so on. Nth phase can be completed in mn number of ways, and this total complete job can be completed in m1 into m2 into m3 into mn number of ways. This is the fundamental principle of multiplication in counting. Here we assume that all the jobs are independent of each other. Some examples to explain the applications of the fundamental principle of multiplications. So let us take an example. Suppose statistics discipline in IGNOU wanted to book the lunch in IGNOU guest house for the experts during an expert committee meeting. The in charge of the guest house explained the lunch menu like this. There are 2 choices for the appetizers, soup and juice. And second, there are 2 choices for the main course, veg and non-veg. And there are 3 choices for dessert, say sponge, rasgulla, gulab jamun and ice cream. And we want to find out how many options were there for the statistics discipline for complete meal. Come to the solution of this problem. We see that after comparing this with the fundamental principle of multiplications, the entire experiment means complete meal, and number of stages of the entire experiment are 3 in numbers. And third, we have 3 options, number of outcomes. For first phase we have only 2 appetizers, soup and juice, and second option we have only 2 options, veg and non-veg. And for third we have 3 options, sponge, rasgulla, gulab jamun and ice cream. So for 3 phases we have 2 and 3 options. So the above situations in the form of a tree diagram can also be written as: in first phase either we can choose, statistics discipline can go for soup or juice, And if we go for the soup, then there are two options. With soup, we can also go with veg, then non-veg in main course. And if suppose we study discipline go with veg, then there are further three options for desserts: sponge rasgulla, gulab jamun, and ice creams. So in this tree diagram, we see that in total 1, 2, 3 up to 12, we have 12 options, and these 12 options can also be obtained using a fundamental principle of counting, which says number of options into first phase, into second phase, into third, 2 into 2 into 3, 12. Let us take one more example on the principle of fundamental principle of multiplication. Suppose in a college there are 40 male faculty and 30 female faculties. The principal of that college wants to select one male and one female faculty to accompany with the students of the college going for a picnic. In how many ways the principal do these selections? Principals have to complete two jobs. First, he or she has to select a male faculty and selection of a female faculty. But there are 40 male faculty, so first job can be completed in 40 number of ways. And there are 30 female faculty in the college, the second job can be completed in 30 ways. So by fundamental principle of multiplications, required number of options for the first job into number of options for the second job. So 40 into 30 is 1200. So college principals have 1200 options to perform this job. Let us take one more example on this fundamental principle of multiplications. How many different number plates of vehicles are possible using two different letters of English alphabets followed by 4 different digits 0 to 9? Here we have to complete 6 jobs. First job is we have to select first letters because we have to take two alphabets. The first positions can be filled in 26 number of ways. Second position can be filled up in 25 number of ways because we have to left one letters that we have already used because repetition is not allowed in this case. And third positions can be filled up with 10 ways because we can use any of the digits 0 to 9. And fourth positions, because we have already used one digit from 0 to 9, so the fourth positions can be filled with 9 options because repetition is not allowed, so we cannot repeat the digits which already has occupied. And in fifth position can be filled up in 8 ways because we have already used 2 digits, one at third place, one at fourth place, and repetition is not allowed, so fifth position can be filled with 8 number of ways. And the sixth position can be filled up in 7 number of ways because we have only left with only 7 digits. 3 digits we have already used among the digits 0, 1, 2 and so on 9. So by fundamental principle of multiplications, this job number plates, 2 alphabets and then followed by 4 digits can be formed in 26 into 25 into 10 into 9 into 8 into 7. So 32,76,000 number of license plates can be formed under these conditions. Let us note one thing from the above examples. In the above example, repetition of the digits was not allowed. If suppose repetition of the digits is allowed, then required number of ways is equal to 26 into 25. First place can be filled up with any of the 10 digits. Second place can also be filled with any of the 10 digits. Then again 10 because repetition is allowed and 10. Here we have subtracted 1. Why we have subtracted 1? Because one of the options is if we have take all the 4 digits 0, 0, 0. So generally this number is not used. So we have subtracted one case which is corresponding to the 0, 0, 0. So total number of cases when the repetition is allowed will be equal to 26 into 25 into 10 into 10, 4 times 10. Now we come to after fundamental principle of multiplication. Now we talk about the fundamental principle of addition. The fundamental principle of addition says that if we suppose first job can be completed in M1 number of ways, second job can be completed in M2 number of ways, third job can be completed in M3 number of ways, and so on. Suppose nth job can be completed in Mn number of ways. So, and in this principle, we want to we have to do only one of the jobs out of the n available jobs. But in previous case, when we were talking about the principle of multiplications, we have to do all the jobs, first, second, third, and so on and nth. But in this case, we have to complete complete only one of the jobs out of the n available jobs. So this is the difference between the fundamental principle of multiplication and additions. Here we have only to do one jobs. In this way, we have the total number of ways is m1 plus m2 plus m3 plus mn distinct number of ways. This is the principle of additions. Let us take the example as we discussed earlier. There are 40 male and 30 female faculty in a college, and the principal of the college wants to select one faculty, either male or female, for an examination duty. In how many ways this selection can be done? Recall in first example, the job that the principal has to perform was the principal was selecting both female faculty as well as male faculty. But in this case, principal is going to select only one of the either male faculty or female faculty. First job can be completed in 40 number of ways because there are only 40 faculty members in the college. And the second job, selection of a female faculty, it can be done in 30 number of ways because there are 30 female faculty in the college. So by fundamental principle of additions, because here principal has to select only one, either male faculty or female faculty, so we will use addition principle, 40 plus 30. This is equal to 70. If we in previous example, the job for the principal is he has to select both one male faculty and one female faculty. In that case, we multiplied 40 into 30. But in this case, principal is going to select only one member, either female faculty or male faculty. So here we will use principle of addition. Let us take an interesting example. In an examination, there are 10 multiple choice questions. First 5 questions have 4 choices and the last 5 questions have 5 choices each. How many sequences of the answers are possible? First questions, suppose there are 4 options A, B, C, D. The students can opt for option A or option B or option C or option D. So first questions can be attempted in 4 number of ways. Similarly, second questions again have the 4 options, so students can select either answer A or B or C or D. Similarly, all the first 5 questions all have the 4 options, so each of the first 5 questions can be attempted in 4 number of ways. So first 5 questions can be written as 4 into 4 into 4 into 5 times 4. 5 questions have 5 options, so first candidate can answers A or B or C or D or E. There are 5 options, but there are 5 questions, so 5 options for each, the 5 into 5 into 5 times. So total 10 questions can be completed in 4 is to power 5 into 5 is to power 5. And fundamental principle, this is the last principle that we are going to discuss in this session, the fundamental principle of subtraction. This principle says that we have some collections, and out of those total number of collections, if we remove those conditions which satisfy some conditions, then the remaining outcome collections, we will have those collections which do not satisfy that conditions. So the fundamental principle of subtraction says that, suppose let us take one simple example. There are 26 alphabets in English alphabets, and our aim is we want to count how many vowels are there. So this can also be completed in other way also. We can count the number of consonants. There are 21 number of consonants, and subtract from the total number of alphabets. 26 minus 21, we will get 5. So in a fundamental principle of subtraction, what we do, we count the opposite events and subtract from the total. And why we apply the fundamental principle of subtraction? Because sometimes what happens, sometimes to count the desired number of our events is difficult or very lengthy. So in that case, what we do opposite of that. and then we subtract from those outcomes which does not satisfy that condition. So after subtracting, we will get those number of outcomes which satisfy that conditions. Finally, we conclude today's sessions. In today's session, we defined factorial notations. Factorial is nothing but it is the product of the first n natural numbers, n into n minus 1 into n minus 2 and so on, 3 into 2 into 1. Next, we defined a fundamental principle of multiplication. It is equal to m1 into m2 and so on. And last principle that we discussed is a subtraction principle. It can be total number of collections minus those which do not satisfy that collections. And in next session, we will discuss the permutation and combinations. Thank you, learners.